Okay, we are now looking at number 4 on page 37, set and drift. It says at 1516, your position is latitude 11 degrees, 41 degrees, 11.3 minutes north by longitude 71 degrees, 48.6 minutes west. You're on a course of 300 degrees per standard magnetic compass with at 7 knots. 1 hour later, your position is, and they give me a latitude and longitude, what was the set and the drift. So again, like all set and drift problems, I like to start by writing a couple of things. I like to write the word true to remind myself to take the course that they've given and make it into a true course to plot. I like to write dr or distance, meaning where am I going to be on that true course after I plot it, given the time I was out there. And I like to write EP for ending position because I want to plot that ending position after I've already found these other things. So this is number 4. Let's take a look. It says you're on a course of 300 degrees. So 300 degrees per standard magnetic compass. What do I have to do with 300 degrees if it's in compass? I have to go from compass to true. So I've got T, V, M, D, C, and I'm going up, okay, from compass to true. So what do I do if I have a westerly error? I have to subtract it. And if I have any easterly errors, I have to add it when I'm going from compass to true. So first thing I got to do is determine what my deviation is for a compass course of 300 degrees. So I have no deviation. My compass is spot on. So I'm going to go with 0 degrees, okay, which means I've got 300 degrees. And the V stands for variation. So I take the variation from the chart, the difference between the true and the magnetic, which is 15 degrees to the west, okay, 15 degrees west. And if I have a westerly error, I subtract. So that's going to give me 285. So 285 is my true. I'll put that down here, 285. The distance, or the dr, is how far I would travel for the time I was out there. So if I'm going 7 knots and I'm traveling for 1 hour, I'm going to travel 7 miles. Okay, if I was going 7 knots for 2 hours, I'd go 14 miles. You can do the math. And next thing is the ending position. So I'm just going to write down the ending position. It is 41 degrees and 14.0 north by 71 degrees 58.1 minutes west. So now that I've got that information, I can mark my starting point on the chart. So again, the starting position was 4111.3, which I've already marked, and 7148.6, which I've also already marked. So now that I've got those marked, I can draw a line in the direction I'm traveling in true degrees, which we determined was 285. So we're going to find 285 on the compass rose, on the outer ring. Okay, 285. Did I say 285? Yeah, 285. Okay, so there's 290. 285 is a relatively easy one to find. And now I come over to my starting position. Okay, and I just draw a long line, 285, in the direction I'm traveling. So I'm going that direction, so I'm just going to draw a long line, 285, from my start point in the direction of 285. Now I determine where I would be given the time I was out there. So the distance, okay, is 7 miles because I'm going 7 knots for 1 hour. So I'm going to measure 7 miles. 5, 6, 7. Okay, 7 miles. Okay, 5, 6, 7. All right, always double check yourself. Take your time, go slowly. And go from your starting point. Make sure your chart is nice and flat. And mark your 7 miles. So there's my DR. That's where I should be in 1 hour, which I like to put a half circle around it just so I know what that is. And now I'm going to plot my ending position. So 71, 58.1. Well, here's 55, 56, 57, 58.1. I'll maybe make a little mark right there. Okay. And 41.14 degrees. Okay. Which you can't see. I could do it over here. Okay, 41.14. Okay, but I can do it on either side of the chart. I might as well work from this side because it's closer. So the first thing I'm going to do is I'm going to bring that line down. I'm going to work off the top of the chart. And I am going to estimate that my line is going to be somewhere around here. Okay, because I'm going 14.1, I think, or 14.0. Okay, so now I will do the same thing on this side. Okay. So I'm going up to 14. Okay, it's 41.14.0. Okay. So there I am. So my position is right here. Okay, here's where I want to be, but here's where I actually ended up. So the current is setting me in that direction. It's pushing me sort of northwest of my intended course. All right, so now that I know that, I can take that position. Okay, and then I can walk it over to the compass. So I'm going to go from the DR to the ending position. I'm going to walk that over here to the compass, and I'm going to, whoops, it went a little bit past it. I'm going to determine the direction that I'm being pushed. So again, I'm supposed to be on the line at my DR, but I'm getting pushed to the northwest. So I'm going to mark the northwest side of the compass on the outer ring because those are in true degrees, and my answer looks like it's going to be, that's 330, looks like 332 degrees. So I'm going to write 332 degrees. This is number 4, by the way. So 332 degrees, okay, is the direction, the set. And let's see what the distance is. Okay, and they ask for the set and the drift. So drift is the speed. So speed, formula for speed, remember back to the triangle, is distance divided by time. So this distance from where I should be to where I ended up divided by the time I was out there. Well, I was out there for an hour, so I'm going to use this distance. Okay, I got one and change maybe. Okay, I'll call it 1. Okay, 1.0 knots. All right, so I came up with 332 at 1 knot. So let's look at the choices. So there it is, 332 at 1 knot. So the answer for number 4 should be C, Charlie, 332 degrees at 1 knot.